For section 6.6, we are focusing on special products of binomials. Basically the same idea as the previous section, we still multiply, but these binomials are special because if you look at the first example, notice that the two binomials are exactly the same. So if we happen to have the same two binomials, when we multiply, we will get a perfect square trinomial. Let me show you. So if you multiply like we did before, x times x gives me x squared. X times 2 is plus 2x. Inner is plus 2x. And the last two terms give me 4. And notice that if you are multiplying two binomials that are exactly the same, the middle term, these two middle terms will also be the same. And when we combine them, we just get 4x. So that's our final answer. So when we have two of the same binomials, this is called a perfect square trinomial. Okay, next, example 2. It says x minus 4 squared. What we want to do for this example is if you have a binomial squared, then the idea is to write it twice, x minus 4 times x minus 4. And after you write it twice, you're going to multiply. This example is the same type of example as example 1. This is also a perfect square trinomial because we have two of the same exact binomials. Let's multiply. We get x squared minus 4x plus 16. Notice again that the two middle terms, the like terms, are exactly the same. Our final answer is x squared minus 8x plus 16. Okay, example 3. We have two binomials. The only difference between these two is that they have opposite signs. This is a special binomial as well. This is called a difference of two squares. You will see once we get our answer. X times x, x squared. Minus 3x plus 3x minus 9. What happens in this case, if you have the same binomial except opposite signs, the middle term will always be 0. This always happens whenever we have this opposite sign. So we're just left with x squared minus 9. This right here is a difference of two squares. Difference because we're subtracting, squares because we have x squared, and 9 is 3 squared. So remember, this is called difference of two squares. Last example, let's just make sure you can see the example. So last example, we have, again, two binomials. Notice that everything is exactly the same except that they have opposite signs. So this will also give us a difference of two squares. So basically, let's multiply just like we did before. X squared minus 3 over 8x plus 3 over 8x minus 9 over 64. Again, the middle terms will be 0. And so we're just left with x squared minus 9 over 64, our final answer. So again, difference of two squares.